Hi friends, here is a nice problem. We have a cyclic quadrilateral ABCD. Cyclic quadrilateral means the quadrilateral whose vertices are on a circle ABCD. Right, all vertices are on a circle. Now, now on all these sides, on the arcs which are on the sides, some point is taken and connected to both the vertices. Right, which are on the same side. Right, for example, P is a point which is on the arc AB, right, and S or Q is a point which is on the arc BC, and R is a point on the arc CD, and similarly S or AD. Some random points were taken and they were connected. Now we want what is this angle? Sum of all these angles P plus Q, whatever. There is any point on B, C, P plus Q plus whatever this angle plus this angle. What is this angle? We don't know anything about the angles of these quadrilateral, and we don't know anything about lengths of the sides. We just know that it is cyclic quadrilateral because the question is asked like this. Automatically, this means there must be some generalization, some general formula which we should be able to derive. Let's see how. Right. So now, if you see, let's take any of these angles. For example, this angle S. This angle S, ASD. Right? Angle S is ASD. Angle ASD. Right. Now let's closely look at this entire circle. Right. ASD is the angle by this R. A, P, B, Q, C, R, D, whatever. This entire arc, right? This entire arc, except this top one, is making this angle ASD here. Now, this arc will make this angle, whatever is this angle, right? If this is, let's say, for now, let's call it AS, then this is 2S, right? Angle at the center is twice the angle which is on the circumference by the same arc. The arc is the same thing. This arc is making 2S angle. So that's why this angle is S. What does that mean? What is this then? What is this angle then? This angle is 2 pi minus 2S. Right? This is 360 minus 2S because the total is 360. That's why it is 360 minus 2S. Very nice. Now let's do the same thing. This is for S. Now let's connect. Let's connect. Let's connect this center and again this point C. Right. Now this angle, this entire arc, CB, CQ, BP, ASB is making this angle R. Right. If this is R, this entire part is 2R. Right. This entire part. This is 2R. That is 2R. Then what is this? That means this angle is 2 pi minus 2R. Right? 2 pi minus 2R. This angle is. Similarly, okay, let's keep this connection. Similarly, let's connect this one. Okay, there is an angle like this. This is Q, let's say. This is Q. Now, this entire arc, BPASDRC, this entire arc is making this angle Q here. Right. What does that mean? This entire angle is 2Q because it is the same arc which is the entire circuit except this small part, This is 2Q. If that is 2Q, what is this? This part is actually 2 pi minus 2 cube, right? Similarly, this part, this entire R is making angle P here. That means this entire part is 2p. This entire part is 2p. What does that mean? This is 2 pi minus 2p. 2 pi minus 2p. So finally, what we have? All four parts, one, two, three, four, which are completely disjunct, all totaling up to 360 degrees. We have 2 pi is 4 into 2 pi minus 2 times p plus q plus r plus s. Right. And this is 2p, 2 pi minus 2p, 2 pi minus 2s, 2 pi minus 2r, 2 pi minus 2p. We are adding all of this. Right. All of this will become 4 into 2 pi minus 2 times p plus r s equals 2 pi. Right. 2 pi is 360 degrees. Right. Which means 8 pi minus 2 pi. 6 pi by 2 equals p plus q plus r plus x, which equals 3 pi means 540 degrees. 3 into 180, 540 degrees. Basically, the angle P plus S plus R plus Q, these angles, all of this should be equal to 540 degrees, irrespective of the quadrilateral, right? As long as these points are within the sides, within the arcs, or these points are on the arcs of the sides, then some of these angles should be equal to 540 degrees. Right, guys? Hope you like this. Thank you.